In the next two lessons for Chapter 2, we're going to be working with objects sitting on an inclined plane, both with and without friction. And when we do that, we're going to run into a little problem with gravity and the direction that it's pulling. So we've got two slightly modified equations that we're going to work with, and I just want to quickly talk about where those things come from, so that you're not just hit out of the blue and wondering where on earth did this come from. So, um, imagine we have some kind of inclined plane. We don't know what the angle is, but currently it doesn't really matter. We have a object sitting on it, and we can consider the forces that will be acting on this object. Um, you'll have the force of gravity working straight down, as one might imagine. We'll have the natural force, which in this case doesn't work directly against gravity. It's working perpendicular to the incline. So the natural force is working this way. Then we're going to have some sort of applied force, and contradictory to that, we're going to have the frictional force. Friction always works in the opposite direction of the object is trying to move. Now, the issue here is that the natural force and the force of gravity are not working directly against each other, which is what we would like. Um, so what we really want to know, rather than wanting to know this force of gravity, which I'm going to show in blue, we really want to know instead this force of friction, which we need to figure out, and we want to know this one that's working straight contrary to the natural force, this other directional force. So I'll just call this one FD. Now, um, we have a little thing we can do here. The green arrow, the force of friction, we can also draw down here. Um, it would be running parallel, so these would be the same directional forces. And this is important because now what we've done is we've created a small triangle underneath with the red, blue, and green arrows. Um, because because this makes a 90-degree angle, and actually the red and green arrows do as well, um, this angle in here, this theta, will actually be identical to the main theta, um, to this one here. And that's important. So I'm going to redraw this little triangle over on the side just so we can see it a bit better. So we've got the red arrow, we've got the green arrow, and we've got the blue arrow. And yes, this does in fact make a 90-degree triangle. And we've got theta sitting up here. Now I'm going to label these sides. So we've got red is FD, green we've got FF, and blue we have FG. So if we think about this angle theta, um, we'll take the sine and cosine of the angle. So if we take sine theta, sine is just opposite over hypotenuse. So in our tiny triangle, that would be FF over FG. Now we really were interested in what that FF is. So by simply multiplying both sides by FG, we can see that FF is going to be equal to FG multiplied by sine theta. So this frictional force here is actually going to be Fg sine theta. Fg, we often just write, because it's the force of gravity, we often write that simply as G. this would be gravity times sine theta. Doing the same thing with cosine, if we say cosine theta, well, that's going to be adjacent over hypotenuse. So adjacent to theta, we have FD, and that's going to be over the hypotenuse, which is still FG. And so multiplying both of those by FG, we get that FD will be equal to FG cosine theta. Now again, Fg is just the force due to gravity, so we can replace that with simply G. And so then we get that this Fd here is going to really be G times cosine theta. Now, what does all of this really mean? I'm going to draw our final result one last time here. So what we're going to see is that when you have an inclined plane and an object sitting on it, your forces are going to be an applied force, the natural force, a frictional force, which will be given by G sine theta, and you'll have this directional force, which will be given by G cosine theta. And this will be your theta. And we're really not going to use this actual gravitational force, the Fg. We're not really going to use that at all, other than to calculate the G sine theta and the G cos theta, because those are the ones that are actually beneficial to us.